Hello everyone, this is Yukabuka and welcome to my home on YouTube. This is the third video in a series of videos I'm making about kobject, and let's get to it. At the end of the second video, we were looking at the kobject_add function and tracing along the functions that were called with kobject_add were called, and in the process we looked at kobject_add_internal, which effectively increments the reference count of kobject's parent, makes sure that kobject is added to the same kset, and if it doesn't have a parent, that kobject's parent is set to the kset's kobject parent, and the function also creates a directory in sys and sets the kobject state in Sisyphus to 1. So that's a high-level overview, and we stopped the last video when in create dir, so that's where we will resume. So judging by the variable name that is being set to 1, we can infer that create dir essentially creates a directory corresponding to the kobject in the Sisyphus hierarchy. So that's effectively what this function does. We can see that this function is present inside the kobject.c file inside /lib. Okay, so first of all we have a function call to Sisyphus create dir namespace, and into that we pass kobject and kobject namespace. Kobject namespace is a function that returns the namespace tag of kobject if its parent has namespace ops enabled, and thus kobject should have a namespace tag associated with it. Right, so the concept of namespace is something it's a different topic worth diving into on its own, and I intend to create a separate set of videos on what kernel namespaces are and how they are meant to work. But for now, let's just not dive into the details of how namespaces within the kernel work. So at this point we can see that we use a function or a macro to retrieve the namespace ops of the kobject, and if there is no namespace, then you essentially return null, else you return the namespace, but it's kobject _ktype namespace, and I'm not sure why that is. So this function is essentially returning the namespace of the corresponding ktype. I'm not sure. That's not what the comment suggests. The comment suggests that it is returning the namespace tag of kobj if its parent has namespace ops enabled. But in this case, we are going to kobj _ktype namespace. I'm not sure why that is the case. So we will continue on. What happens next is a sysfs create dir namespace, and this function creates a directory for an object with a namespace tag. Right, so once we've figured out what namespace the kobject belongs to, this is the function that creates a directory in that specific namespace. And you can see that this file is present inside fs sysfs, and the file is named dir.c. So I think it's given the location of the file and the function name, we can conclude that this function is what eventually creates the file inside the Sisyphus hierarchy. We won't go into this in depth now. We can perhaps look at Sisyphus in depth later on. At this point you have a function called to populate dir. Populate dir is also declared within lib-kobject.c, and the comment suggests that most subsystems have a set of default attributes that are associated with an object that registers with them. This is a helper called during object registration that loops through the default attributes of a subsystem and creates attribute files for them in Sisyphus. Got it. So the idea of a Sisyphus hierarchy is that it allows the kernel to expose certain values to user space. It also allows user space to set certain specific values in the kernel through Sisyphus. So I believe that the values that you set are what are referred to as attributes in this case, and for each attribute that the kobject supports, a specific file is created within the directory for that attribute, and that is what the function does. We see here that it takes the type of the kobject, and once it does that, it looks at the type and the type's default attributes, and for each attribute creates a Sisyphus file. Got it. I wonder if the purpose of having a type inside kobject. So far, let's try to recollect the occurrences of ktype within the kobject add and the kobject init function. Inside the init function, the kobject's ktype is set, and inside the add, we have seen some places where, I think it's inside kobject add internal, we see some places where the type might be used. I don't remember clearly. No, I don't think either of these use the type. So the type is effectively used over here. I don't think the type is really used elsewhere. And the way it's used is to populate the directory within the Sisyphus. So perhaps that is an indication of why there is a type inside kobject, inside a struct kobject. Okay, so populator is there, and if it fails, then the Sisyphus directory itself is removed. That makes sense. There is a reference counter inside kobject named SD. So the SD is supposed to point to the Sisyphus root. So I wonder if it's set somewhere. Yes, it is definitely enabled over here. Let's look at what Sisyphus get does. Okay, Sisyphus get is a kernfs get on kn, where kn is of type kernfs node. Okay, so I believe the kernfs node probably would have a refcount_t or a kref instance within it. We can check that out. Let's see what kernfs node is. Does it have a reference counting mechanism within it? Well, there is an atomic_t count, so perhaps that is the counter. We have no, I don't see a ref count, so perhaps this value is what is incremented. Let's look at what kernfs get does. Yes, so the kn_count is the reference counter inside this. Fair enough. Okay, so what else do we have? Once it increments the reference counter of the kernfs node instance, the children need to be filtered based on their namespace tags. Enable namespace support on SD. So in this case, we are effectively getting the ops of the namespace. It is hard to dive into what exactly is going on in here without looking at the details of how namespaces work within the kernel. So for now I will not dive into this. Let's have one more quick look at this to make sure there isn't something that can be easily understood that we are overlooking. That's fine. For now, for this pass I will ignore looking at these files. So in short, creator creates the folder within /sys and populates the sys directory with the attributes of the kobject. Sounds good. And once creator is done, we return to kobject add internal. Once that is done, we return to the caller function of this, which I believe would be the kobject_add function. So if you go inside kobject add, yes, that's it. So at this point we can go back into the documentation and read what they have to say. This properly sets up the parent of the kobject and the name of the kobject properly. Right, we did see in the code how the name of the kobject is being set. If the kobject is to be associated with a specific kset, kobject_kset must be assigned before calling kobject add. Right, we did see that there was an if check to see if the kobject had a kset associated with it and so on. If a kset is associated with the kobject, then the parent for the kobject can be set to null in the call to kobject add, and the kobject's parent will be the kset itself. Again, the kobject's parent will be the kobject inside the kset, not the kset, right? Unless I'm missing something. So this is something that the documentation is a bit ambiguous about, and the comment is ambiguous about as well. I had called this out in the last video. Okay, so as the name of the kobject is set when it is added to the kernel, the name of the kobject should never be manipulated directly. If you must change the name of kobject, call kobject rename. Kobject rename does not perform any locking or have a solid notion of what names are valid, so the caller must provide their own sanity checking and serialization. I see. Okay. So kobject rename seems to be a function that will let you rename the kobject to pretty much anything. So if you have a kobject rename function, it is the responsibility of the caller to provide mutual exclusion between the different calls of kobject rename on the same kobject, and to ensure that the new name is valid and won't conflict with other kobjects. I wonder if kobject has some sort of a mutex you can acquire. No, it does not. So I wonder how you can provide mutual exclusion. Interesting. Okay. So in this function, what we have is a bunch of function calls to manipulate the name of the Sisyphus directory, right? So here we get the path, we do a kmalloc to allocate space for the path, and into that we give dev path old and %s as dev path. Okay, but where is that used? You have an envp used here, and where is the envp used again? Right, so the env is used to create a U event. So this function is mostly used only for the network interface. Some hot plug package track interfaces by their name and therefore want to know when the name is changed by the user. Right, okay. So that is used to broadcast an event into user space that the name of the kobject has been changed. But that's pretty much it. Okay. Right, so at this point, is there anything that is very peculiar about these implementations? Let's see. We can dive into each of these functions one by one to get a clearer idea. Kobject get should be incrementing the reference count by 1, right? Yes, that is what it does. After that, you get to kobject get path, which returns a char star. So it returns the path, and what it does is that it will generate and return the path associated with the given kobject and kset pair. Right, so you have a second argument to that to denote what the type is. Okay, so I guess you cannot call these functions while holding a spin lock. So this is the function called get kobject path length, and what it does is you have a parent pointer pointing to kobject, and while parent I see what they're doing here. Until the parent is null, they keep iterating with parent is equal to parent arrow parent, and they get the kobject name and then they add it to length and then return it from the function. Yes, that makes sense. And they allocate space for the path. That sounds good. And then they fill the kobject path. I believe they would do this in reverse, because yes, that is what they're doing. So they start from the node at the very bottom of the hierarchy, or the node that kobject corresponds to, and they work their way up, and at each node they find the name of that node using kobject underscore name, and then copy it to the end of the buffer. Yes, that makes sense. Length keeps decreasing, and you strncpy to path plus length. Yes, that sounds good. After that, you have a kmalloc here for strlen dev path plus 15. So dev path is the string that we just received, that is the kobject path. You allocate that plus 15 as dev path string, and then effectively you are prepending this to the path that you received, right? And we saw earlier that the only place it's used is in envp, and envp is used for uEvent. That's it. At that point, you have an strdup called, and name and dup name point to that, and then finally you call the function that does the actual renaming. How does this function work? This function gets the parent and then calls rename ns. Yes, so here, as you can see, when the rename happens, there is a mutex that guards this critical section. Curiously enough, the lock is only unlocked here. Okay, there are no other return places. Okay, there are no other points in the function that exit the function, so that's fine, I guess. So it checks if the node is active, and it performs the renaming over here. It copies the new name over, and once the copying is done, it does an unlink of the sibling. So I wonder, why does it have to go through, why does it have to do that? Unlink the kernfs node from the sibling RB tree. That is, try to unlink the kernfs node from its sibling RB tree, which starts from kernel parent dir children. I see. So all the previous children of the directory are being removed, it seems, which is a bit strange. I could be wrong here. You might want to check again. And then you have another function called kernfs link sibling, where I imagine the siblings are added underneath the node again. We will not immediately go into the details of how exactly it does this, because it's a different subsystem altogether. However, we can look at it another time. So the documentation did suggest that kobject is tricky because it brings together quite a few subsystems, and as we can see by browsing the source code, this is very much true. Okay, so getting back to the documentation, there's a function called kobject set name, but that is legacy cruft and is being removed. If your code needs to call this function, it is incorrect and needs to be fixed. Okay. To properly access the name of an object, use kobject name. Yes, we did see this function being called from within rename. There is a helper function to both initialize and add the kobject to the kernel at the same time, and surprisingly enough it's called kobject init and add. Fair enough. The arguments are the same, and the individual kobject init and kobject add functions are described above. Okay, let's have a quick look at kobject init and add to make sure that it's not doing anything too surprising. And yes, it looks pretty much the same as kobject init and kobject add brought together. That makes sense. That sounds good. Okay. So in the next video we will look at U-events and continue this series on kobjects. That's it for this video. Hope you enjoyed it. Click like and feel free to write out a few comments if you have any. Thank you.